All right, so we're doing FRQ1. It's a situation where an object is launched. It's a dart, and it lands on a bullseye. Hi.
Email?
That would be great.
Okay, awesome.
Thank you very much. It's launched horizontally. This is H, and this is D. If I read that first paragraph in the question, it says the exact same thing. It says that this object was launched horizontally from a height of H and lands a distance away, D. So what information do I already know? In the horizontal and the vertical, what information do I already have? Can anybody tell me anything? Liam?
Acceleration in horizontal is 0.
Absolutely. Anything else?
Acceleration of vertical is negative.
Sure darn dippity.
Initial velocity.
What for what?
Vertical is 0.
Initial velocity in the vertical is 0 because it was launched horizontally. Awesome. Anything else? How far did it go in the horizontal? We do know. D. We do know. D. Delta X is D. Almost. Which way did it go? Did it go up an H or did it fall down an H? It's negative H. Delta Y is negative H. All right? Just as an FYI, something I can see writing on the wall on an FRQ question is true some of the time. There are no numbers here. And if I keep reading it, I'm not going to get any numbers. So whenever I'm doing a question without numbers and I need to put in negative 9.8, I write it as negative G. They don't really want me to have numbers. If you, on the second part of this, in the writing the equation part, put 9.8, that's fine. For the FRQ, fine. They have to take the answer. The problem is for an MCQ question like this, I can guarantee you the multiple choice answer is going to say G instead of 9.8. So on the FRQ, if you use 9.8, perfectly fine. But on an MCQ question, you're going to see G. Yeah?
Why is it negative G?
Because our acceleration is negative 9.8, G only stands for 9.8. G is not negative inherently itself, so I would always have to put negative G.
Wait, so gravity is scalar?
The acceleration due to gravity is not given, we give it a direction. We could have said that positive direction is down, and then it would have been positive 9.8. So since we don't decide it, the constant G only represents 9.8. The constant by itself doesn't determine which direction is positive or negative. Does that make sense? Okay. So I'm going to use G there. Okay, so the first thing it's asking for is some graphs, just like we did for a warm-up. It's asking for the horizontal and the vertical velocity graphs. So we're going to use all of this super sweet information that we know to help us out. So in the horizontal direction, right, we know that acceleration is 0, so what should the slope of my velocity graph look like? Should it be linear, curved, or constant? Constant, right? It should be constant at 0. So then also, which way is it going? Positive, right? It's coming to the right. So I would have a positive constant velocity. Done. In the vertical direction, I know where I start. What's my initial velocity? 0. And then what should my slope be for this? It's going to be constant and negative. So I have a constant negative slope. So 0 means flat. If you're a person who's out here using constant for 0, it's kind of like square and rectangle, right? A constant could be a constant at 0, right? So 0 is kind of constant because 0 is a constant at 0. But saying 0 is more specific than saying constant. So this is a constant negative slope. This is a constant 0 slope. They stay the same the whole time. The slopes, right, are the same the whole time. So yes, I can use constant for both, but if I'm being specific, this is a slope of 0. This is a constant negative slope.
Could I say linear for V?
Yep, linear, and you would say, you can't say linear for this. You would have to say constant, yeah. So a little bit tricky, that verbiage with constant. Questions about I? All right, let's get to 2I. Here's where the fun begins. It's like 2 I's. So that's what that is. It says, using a kinematic expression, what does that mean? One of the kinematic equations. That's all it's saying. It's saying using a kinematic equation. This is something this type of FRQ will do every time. It's just going to tell you what equation it's doing first. So sometimes it'll be a kinematic, because that's the only ones we learned. It might be a expression of conservation of energy, an expression of conservation of momentum. It could be an expression of Newton's second law. These are all ways that that could start. But for today, it's asking for a kinematic equation. Those are the first 3. All right? It's saying derive an expression. So that means I'm getting an equation. And we have to pay really close attention to what I'm allowed to write the equation in. So it says I'm allowed to use H, D, and physical constants. Right now, that's limited to G. G's our physical constant. That's that guy. Could it be other physical constants in the future? Sure. But for today, it's just G. So they're asking me to solve for that launch velocity. So they're asking for the horizontal velocity. What is VL? What is VL? They even gave us additional information. How long does it take for us to get to the bullseye?
1 second.
What?
1 second.
No, it says it equals T1. Read the question, right? It says T is equal to T1. So at first glance, you're like, wait a second, this is super simple. I'm just going to solve it. I'm going to write out the kinematic equation in the x direction. Delta x equals v naught t plus 1/2 at squared. Delta x is d. I'm looking for that initial launch velocity. Time is t1, and the acceleration 0. I've done it. I've written an expression. Is it correct? Why? There's no h, and what is there that I'm not allowed to have? T1. Oh, no. I can't have T1 in my equation. So I need to go figure out what T1 is. I can't have it in my equation. Yes, I wrote an equation. It's the correct one. I'm going to use it. But I can't have T1 in there. So I'm going to use the vertical information and figure out what T1 actually is. So I'm going to leave this here. It's not wrong. I'm going to save myself some space by erasing that. But now I'm going to solve in the vertical direction. Which of my 3 kinematic equations should I use in the vertical? Look at the information you have. This is not a guess. This isn't a hard question. I read the equations. Which one?
First one.
No. The second one. I feel like people actively avoid the second equation. They're like, no, but that one's ugly. And so you're like, can I do the first one? Are you like, can I do the first one? And I see a lot of bias on wrong answers of you use the first equation when you weren't supposed to. Don't be afraid of it. I know it has a square in there, but it's okay. So, change in y is equal to Vy initial t plus 1/2 at squared. So negative h equals, hey, look, that's 0. How handy. Because my initial velocity was 0. So it equals 1/2 negative g t1 squared. Don't be afraid of algebra with just letters. Don't be afraid of algebra with just letters. If this is a task we are going to be dealt a lot. Solve for T1. It's just a little algebra. If I wanted to get T1 by itself, what am I going to divide both sides by? 1/2 negative g. That gets me 2h over g How do I get T1? Square root. T1 equals the square root of 2h over g. Cool, I've got it. I'm going to use it. D equals VL times the square root of 2h over g. What's my expression supposed to be for? Is it supposed to be solved for distance, height, gravity, or initial velocity? Initial velocity. So what should I do? Divide. Yeah.